folks, so in the previous video I said that when carbon and fluorine form a bond, they create a polar bond. And that's true. When you have one carbon and one fluorine, there's a difference in the electrons, there's an unbalanced kind of charge going on in that bond, and so that is a polar bond. But what if we have a molecule made of carbon and fluorine? Is it still polar? Does the shape influence the polarity of a substance? Well, the answer is yes, the polarity influences the shape. See, polarity is a difference in charges. It's a difference in where the electrons are in an atom. If there are a lot of electrons in one place and not a lot in another, then that's going to be polar. And when we look at CF4, we've got a bunch of valence electrons on fluorine. We've got 8 specifically, 8, 8, 8. And there's also 8 valence electrons on carbon because of all of these bonds that carbon is forming. And so when we look at this molecule, there really isn't a difference in the electrons. There isn't really a difference in the charges in this molecule. And so while a carbon bonded to a fluorine is a polar bond, carbon bonded to 4 fluorines to create CF4 is actually going to be non-polar because there isn't a difference in the electrons. All of the electrons over the molecule are fairly evenly spread out. The density of the electrons is the same across the entire molecule. Okay, cool. So let's look at water real quick. Let's look at dihydrogen monoxide. So with dihydrogen monoxide, the oxygen atom has a lot more electrons on it than the hydrogen atoms do. And so based off of the shape of the molecule, water is polar because there's more electronegativity going on that central oxygen than there is on the 2 hydrogens. A really funny joke that a friend of mine told me is if you've got a bear from the Arctic and it goes in water, never mind, that doesn't actually work. We're going to cut the video before I get to that joke because they haven't talked about like dissolves like yet. Bye.
So, Christopher, I do have one